All right, let's get started with 2.5 linear regression best fit. So we are going to get into scatter plots here, and then we're going to talk about linear regression and the lines of best fit together in class, because there's a lot of work on those with calculators. So for next class, you're going to want to bring your graphing calculators. You're going to need them in class. All right. Okay, so in this section, in this video, we are going to talk about these two things. Talk about positive and negative association and linear and nonlinear association. And then best fit, we will talk about that in class together next class. All right, so scatter plots. So if we have a lot of data in a real world example, such as if we're talking about is age predictive of texting speed, is the level of pollution in a country related to the prevalence of asthma. Now, you wouldn't just ask one or two people or look at one or two pieces of data to get the answer to that. You would look at hundreds or maybe even thousands. And if you did that, nothing would fall into a perfect straight line or even a quadratic equation. Information would be all over the place, but potentially would be related, and we might be able to kind of assume some things about it using different equations. All right, so we do have two different types of variables that we want to talk about. The independent variable, or the predictor variable, that's going to be x. That's going to be your input. And then your dependent variable, that depends on whatever your input. That's the output, that's your y. All right? So let's do an example. So the Olympic decathlon is an event, well, it's an Olympic event, where 10 different events are compiled to get a winner. So each competitor has to do the 100-meter dash, and then they do the long jump, and then the shot put, et cetera, et cetera, et cetera. And in the end, they add up all their scores, and the total scores determine the winner. All right? So what we want to look at this, and we say, okay, could we look at just one score and see if that would be helpful to predict who we think are going to be the winners? So we're going to say, are the people who are fastest in the 400-meter dash, does that correlate with the people that have the highest scores? So here's all the data from that Olympic event. A whole bunch of competitors. We have their 100-meter dash times. We have their long jump scores. But we're going to compare the 400-meter time with their total score. Okay? All right. So if you put that into a scatter plot, here's what a scatter plot is. You put the input on the x. So we're going to say, does the 400 determine the total points? Another way of saying that is, do the points depend on the 400 meters? So the dependent one is your y. And so every dot here represents one of these scores. So 4836 is one of the x's, and that matches up with this y of 8893. Okay, so that's in here somewhere. So every single dot is a specific competitor. So if we look at this, do we say, is there any correlation? All right, are they related at all? And I think so. It looks like the faster you are, right? So faster would be on this side over here, right? The less amount of time it takes you to run the 400-meter dash, the higher your score is going to be, all right? So we would say the faster people probably end up with higher scores. Now that makes sense just thinking about it, but it is supported by the data, okay? But it's not perfect because you do have people all over the place. This person here is actually faster than this person, but they have the same scores. This person and this person are just about the same speed, but the person up here has a way better score than that person. So it's not perfect, but it does give us an example, and it lets us predict things. Not perfectly, but we can predict them. All right? Okay, so to do this on your calculator, you're going to want to look on page 232 in your textbook. It gives you all the steps, and we're going to go through that in class together, right? But at least take a look at that in your textbook to see how to do that. And again, bring your calculators to class. Okay, but in this video, let's talk about two things: direction of association and linearity. All right, so we have a graph like this. Linearity simply says, are we going in a straight line, or does it kind of curve all over the place? So this is definitely a linear relationship, right? You could draw a line through this, and it would represent this set of points fairly well. So then the other thing is the direction of association. Which direction is this line traveling? This is going from high to low, if we look from left to right. And so we're going to say this is a negative association. And we can also talk about how tight is our grouping. So this one is fairly tight. Everything would be very close to a line that we could draw through the middle. So this would be an example of a positive association. Definitely still linear. Looks like we could draw a line for it. Come back. And this is a little loose, all right, but still somewhat discernible. All right, so it's looser than this first one, but now we get into rather loose. Still looks like it's trending downward though. So if it looks like it's all trending in the same direction, we'll say it's linear. All right, it's still definitely a negative association. It's heading down. All right, this is an example of nonlinear. You looked at this kind of curves like that. It's going down and then back up. So nonlinear, fairly tight. We're pretty close to whatever curves we would be going through here. And this is nonlinear. So we do not have an up or down association. It's not positive or negative in terms of an association. And then we might have dots all over the place. All right, so we can't see a relationship because it's just too loose at all. So no discernible relationship, linear or otherwise, and no degree of association, not positive, not negative. All right, that's it for this video. Again, make sure to bring your calculators to class. We're going to go through line of best fit in class together.